In this recording, we're going to continue our study of completing the square, specifically turning it into vertex form so we can identify the turning point or the vertex. As it says here, it works best when a equals 1. We've seen that. You don't have to factor out the leading coefficient. And it works best when b is even as well, because then when you take half of that b value, you still have an integer. But we can do it in every case, even the messy ones, and that's what we're going to work on here are some messy ones. So, if you have a situation where you have to put it into vertex form and identify the turning point, we have here a leading coefficient that's not 1, so what we're going to do is factor it out. All right, so we're just going to write it like this. We're going to take our 3 and factor it out. And that's going to leave you with a fraction, right? 2/3. All right, we can handle that. I'm just kind of bracketing this in. Now I'm going to do what I did before. I'm going to identify the portion x squared, put a little parenthesis there, x squared plus 4x, just that piece, minus 2/3. I'm going to kind of separate out those two pieces. And I want to complete the square for the x squared plus 4x. So let's kind of think about that over here. We're going to go with our little box. All right, if I'm splitting the 4x, well, that means 2x and 2x, right? So I got my x squared. I'm going to split it evenly because I want to create a square. 2x and 2x. And of course, that gives me x up on top and a 2 on either side. Well, to complete that square, I have to add a 4. Well, let's show what that will look like down here. Just basically recopy what I've got. And I'm going to put in here, I'm going to use a color here to show you. I'm going to put in here the 4 that I wanted to add to complete the square. Still have the minus 2/3. But in order to balance things, we have to subtract the 4. All right. And now we just have to clean all this up. So we've got the 3 still out in front, factored out. This can be expressed, well, it's a square with x plus 2 as its two factors. You add these, so let me just think about that. I want to get these in thirds. Negative 4 is negative 12/3. I'm going to add that to negative 2/3, so that comes out negative 14. That 4 didn't come out too well. Let's try that one more time. Negative 14/3. All right, and I'm just going to distribute the 3 to this term. That's going to give me 3 times x squared, x plus 2 squared. And when I distribute 3 times negative 14/3, I just get the integer negative 14. So now I've got it in vertex form. So I can see the vertex. Okay, so normally, as we said before, all parabolas that aren't shifted have their vertex at 0, 0. So this one has a vertex shifted 2 to the left. So that's going to mean a vertex of negative 2. And this one shifted down 14 units, so its vertex is at negative 2, negative 14. So that's the vertex or the turning point. So we've got that, and we have our vertex form. Okay. Why don't you try this one? Play the recording when you're ready to get some feedback. Okay, so for this one, we're going to factor out our 2. Very similarly, and it's going to be x plus, now when I divide by 2, I've got a 3 here, x squared plus 3x, and then when you divide by 1, I divide by the 1 by 2, you get half. I'm going to use a decimal here. Would be the same if I used a fraction. All right, so now I have to complete the square. So let's complete the square. Again, you might not be drawing the box anymore, or you might still be. I like the box just as a visual, so I'm going to take that 3 and split it in half, so that means 1.5x. Okay, when you square 1.5, maybe you have to go to a calculator. 2.25 is the square of 1.5. So that means an x up on top, and a 1.5, x, and a 1.5. Let's come back over here. And that means we've got x squared plus 3x plus, I'm going to leave a little space for the term I'm going to be adding, plus 0.5. Leave a little space for the term I'm going to be subtracting, so I don't have to balance things. I'm going to simultaneously add the 2.25 that I want to complete the square and take away 2.25, so that balances, right? I basically added a net of 0, so I didn't change its value any. All right, now just clean it up. Still the 2 is factored out. I can now factor this into square factors, 1.5 squared. Now I put these together. Well, that's going to make it negative 1.75. Now let's just distribute our 2 back. So we've got y equals 2, parentheses, the quantity x plus 1.5 squared. And when you double negative 1.75, you get negative 3.5. Now I should be able to identify my turning point. So I'll just abbreviate here, turning point, negative 1.5, comma, negative 3.5. Alrighty. All right, so now we get into this example. I'd like to see if you can get as far as you can with this example and then play the recording when you need some feedback. All right, so it says, what's the coordinate of the turning point of any parabola? So as you saw, it's always the opposite of this. So the x coordinate is going to be negative of the b over 2a. Now, where have we seen that before? Oh, yeah, that was the axis of symmetry. Cool, good connection. So it's the opposite of here. Next, it says, all right, use this formula to find the turning point. Well, if you haven't done so, if you didn't get any further than this, go ahead and figure out b and c, and then use your calculator if you have one to verify d. Okay, so for right here, we should be doing y equals, and I'm going to find out, I have to do the x equals. Let me start with that. X equals negative b over 2a, so negative 10 over 2, x equals negative 5. All right, so I know the x coordinate of the vertex. Now I have to just sub in that to get the y coordinate of the vertex. Okay, when you do that math there, you're going to get a negative 27. Now you know the x and the y. Now here it says verify it by putting into vertex form. Okay, cool, we can do that. This is actually a lot easier than the ones we just doing above, right? It's got a nice even number as the b, a nice 1 as the a. So crank that out if you haven't done so. All right, in terms of checking this, we're going to go y equals, I'm just going to go through this quickly and you can watch. All right, so at this point, we see that the vertex is at negative 5, negative 27, which is what we said it would be. All right, so that checks out. Finally, it says verify both answers by putting it into your calculator. And let's do that. So let's pop over to the calculator if you have one. If you don't, you can just kind of watch along. We're going to put in that original equation, which is y equals and now we're going to peek at the table. And we can just see at negative 5, we see some symmetry around negative 5, and we see that in fact negative 5, negative 27 is the point where it turns, right? The turning point. All right, so we can just say check. And now we're just going to finish out these last two problems. It simply says use x equals negative b over 2a to find the turning points. Okay? Play the recording when you're ready. So I'll just kind of work out these fast so you can see the answers. Hopefully you got as far as you could. Thanks for watching.